Hey guys, what's up? So in this video, we are gonna see how an SSH key fingerprint is computed. For example, when you usually generate an SSH key pair, like I have here, one is the private key and another one is the public key. You could see the content. This is the private key and this is the public key. This key pair is actually generated using the command ssh-keygen, and if you just press enter, it's gonna generate a key pair for you. So once you have the key pair like I have here, you could just use mechanisms to compute it. So when you go to platforms like GitLab, for example, I have the key uploaded here. You could see this is my public key and you could see the fingerprints like MD5 sum, SHA256. So let's discuss on how exactly this MD5 sum is computed. Then we will see how SHA256 is computed. The MD5 sum is actually straightforward. In order to compute the MD5 sum, all you have to do is just use AWK, and you could see that this public key file actually has three sections. One is the algorithm, second one is the public key, and then a comment. It could be usually your username and your host machine identifier. And what we are doing here is we are extracting the second part of it, like we are using by default the space as the delimiter. And so we are extracting the key, which is a base 64 value, and we are decoding it using the base 64 command and then giving MD5. It will compute the MD5 sum. And you could see there is the exact value that you see here, just colon separated. That's it. Now let's see how the SHA256 is computed. For SHA256, the computation has a slight difference. For example, the initial part remains the same. So you could see that I'm opening the public key, I'm extracting the key alone, that is the second part in this, and then using base 64 to decode it, and then instead of MD5, I'm using the SHA256 algorithm to compute the checksum. And now if I press enter, till this much, you could see it generated the SHA256, but that is not the value that is shown here. So what they are doing is they are again computing or converting this hexadecimal value into a binary value, for which they are using a utility called xxd, and then minus r is to reverse. Usually xxd is used to convert binary to hex, and now we are converting hex to binary, and minus p is so that it is just plain output with no column numbers or line numbers, etc. And then again computing the base 64 of the binary. Now you could see that this is the exact value that will be shown in your GitLab or GitHub, where they are actually computing the SHA256. Also, you could use an alternative command that is already provided as part of ssh-keygen, where you could just specify -l and minus uppercase e, then give the corresponding algorithm. For example, if it is MD5 sum, then specify the file name. In our case, it is sshkey.pub. So now you could see that it has also computed the same value, and you could do the same with MD5, and you are going to get the MD5 sum. And if you notice now, there is an additional equal to here when we manually computed, and there is no equal to here. That is because when we do base 64 encoding, there could be a chance that there is additional padding that is applied. That equal to appeared just because of padding, and the underlying binary will be the same for both the one with and without the padding. Some platforms may show equal to and some platforms might not, but if you are using a standard tool, it will result in this without the padding. Hope you guys enjoyed this video. Thanks for watching. Don't forget to like and subscribe. Thank you.